Amira Shahinda binti Yusri. So we chose the campus equipment borrowing system because the campuses have a lot of devices or equipment such as laptops, projectors, cameras, and etc. Take for example the SRC, the Student Representative Committee from UniKL. They have a lot of equipment under their care and they can borrow it out to other clubs if they wanted to. So after filling in the necessary documents and forms, keeping track of all of these manually can be time consuming, and it can be difficult to track of who borrowed the system, when it was borrowed, when it should be returned. So that is what campus equipment borrowing system is all about. So why it is suitable for database? For our first point, it stores, manages user equipment and borrowing records efficiently, because we need to store these details, the equipment details, the borrowing details, the admin records, and so on and so forth. And having a database makes it easier to just store all of this. For the second point, it basically just means that it will help you reduce redundancy, and having a good database can improve data accuracy because everything will be organized and laid out neatly. So for the third point, make it easier to track equipment availability and borrowing activities, especially for the tracking equipment. Every equipment could have its own primary key or like unique key, so it's easy to identify and to find which document someone wants, or like, you know, a specific equipment. It can help with the availability. You can see if it's still available or if it's been rained out, when it should be returned, and so on and so forth. That's what it also means for borrowing activities. You know, you can tell if it's when it's going to be returned, if it's still returned, if it's late, you know, so it's just easier to manage it and track everything. For the last point, for example, our system can show users borrow equipment, who borrows the equipment the most, which department uses the equipment the most, what equipment is returned damaged, and so on and so forth. And these could help admins make better decisions. It also means that it can help It also means that it can help generate reports and useful information from the stored data, especially from the SQL.
Okay, Assalamualaikum warahmatullahi wabarakatuh. And I'm Haikal Bishukur. Then we go for the mobilization process. And as you can see here, we have the unnormalized form that we have the borrow ID, borrow date, due date, actual return date, user ID, user details, admin details, and equipment borrowed. So we want to make the first normal form, second normal form, and the third normal form. Okay, for the first normal form, we create the first selection of each data that will be concluded, with each borrow ID, username, equipment name, admin name, borrow date, and due date. And for the first normal form, each field has only one value only. And for example, laptop and projector are separate into different rows. Okay, then we go next for the second normal form. In the second normal form, we have a separate into a proper table to reduce repetition information. Then that we have the table that concluded is user, admin, equipment, borrowing, and that's the only one for the second normal form. And for your information, user details, admin details, equipment details, and borrowing details are separate into their own table, and this to avoid repeating the same user or equipment information many times. Okay, then we go through for the third normal form. For the third normal form, we have the final tables that are organized so each table focus on the one main thing. As you can see it, we have the user, equipment, and borrowing. Also borrowing details. that only for. So for the information, borrow details is added because one borrowing record can include more than one equipment item. So this helps connect borrowing and equipment properly without repeating too much data. And that's all for the normalization form.
Hi, my name is Amir Hakim. Today I will present our entity relationship diagram and explain the cardinality of relationship in our system. This diagram shows the main entities in our database: user, admin, borrowing, borrow details, and equipment. Each entity has attributes and they are connected through relationship that define how data flows in the system. First, we have user to borrowing, one to many. One user can make many borrowing. For example, a student may borrow multiple items over time. After that, we have admin to borrowing, one to many. One admin can manage many borrowing. This ensures proper monitoring and approval of transaction. Third, borrowing to borrow details, one to many. Each borrowing record can have multiple borrow details. For instance, one borrowing transaction may include several items. Lastly, equipment to borrow details, one to many. One equipment can appear in many borrow details. This means the same item can be borrowed multiple times by different users. For the key point, these cardinalities show how our system support multiple user, admin, and equipment transaction while keeping borrow records organized.
We go to the next part, which is create the SQL queries. So this is the main table that we have created: the admin, borrowing details, equipment, and user. And this one is very important that because we want to use the data from each table, each section that we choose. So for the first queries is we want to make the most active borrowers. This query is used to identify the user who borrow equipment most frequently from the system. So we go to the SQL, then we type select u dot user ID, u dot username, u dot department. Then we count p dot borrow ID as total borrow. Then from user u we join the borrowing b on u dot user ID equal to p dot user ID. And then we group them by u dot user ID, u dot username, and u dot department. Then we order by total borrows, EESC, and close. Okay, then we generate, and we got the table for the most active borrowers. We take the information from the user, is user ID, username, department, and from the borrow section is the total borrows. Okay, for the first queries, most active borrowers is done. This is the code, and we go through for the second queries, which is items borrowed per department, which is this query is used to analyze which department borrows the highest number of equipment items. So first one is select. Don't forget select. Then we take from the department, u dot department. Then we sum one as total items borrowed. Then from user join borrowing b on b dot user on u dot user ID equal b dot user ID. Then we join borrow underscore details, borrow details with on b dot borrow ID equal bd dot borrow ID. Then we group them by u dot department. Then order by total items borrow, and close up the ESC. Then we generate it, and we got the table that we want for the items borrowed per department. So we have here the department and the total borrow
Here
item.
I will show you query 3, average borrow duration per category. This query is used to calculate the average borrowing duration for each equipment category. Let's go for the script. First, we type select. And then E dot category. Average. Open bracket. And then date div open bracket b dot actual return date. Then b dot borrow date. Close the bracket. Then as avg borrow days. For the third line, type from borrowing B. After that, type join, enter, borrow details, BD, on, B dot borrow ID equals to BD dot borrow ID also. Join equipment E on BD dot equipment ID equals to equipment ID. I mean equals E dot equipment ID. For the last line, group by E dot category. Then go. So here we get the output. Hi, so for this part, I will show how to do the query for which is longest or the shortest borrow per equipment. This query is used to identify the longest and shortest borrowing duration for each equipment item. So let's jump into the script. First, type select, then e dot equipment name, max, open bracket, div, open bracket, e dot actual return date, e dot borrow date. close the bracket twice, AS, then write longest borrow. For the third line, for the minimum. Inside the brackets, it's also same with the second line. But at the back is different. We need to type shortest borrow. Then type from borrowing B, join borrow details BD, then on B dot borrow ID equals to BD dot borrow ID also. So that type join equipment E. So the last is on BD dot equipment ID equals to E dot equipment ID. For the last line, type group by E dot equipment name. Then hit the go button. So here's the result.
Okay, so for query 5, the late return offenders query, this is to identify users who return the equipment late or if there's any equipment that was returned after the due date. So to start off, you will have to type select u.username, enter, tab, count as late return, S, and then backspace from borrowing B, from borrowing B, you will type join user u, and then you will have to type on the ID equals to enter, and then backspace where the actual date, dot actual return date, dot and then I username, enter, and lastly having account become 1. Then we click on go. Center at line 2. Line 2, count as late returns. Forgot the promo there. Train user on B equals to B. Oh, okay, sorry. It's not class. U dot user ID. Sorry, U dot user ID. And then where B actually returns the dates, supposed to be the due date, and then having counting. Okay, let's try again with the go. Okay, there we go. So as you can see here at the bottom, this is the output for query 5. Okay, back to the SQL. Let's move on to query number 6, the equipment return damage, where the query is used to identify equipment items that were returned in damaged condition or equipment that were returned damaged. So let's select E dot equipment E dot equipment name, comma, and then tab as damaged goods or damage count, sorry, damage. And the space from borrow underscore, sorry, underscore details, BT. And then join equipment equipment. The tab on BT dot equipment ID equals to B dot equipment ID. Enter and then backspace where BT dot item condition on third equals to, oh, sorry, equals to damaged. And the last line is proved by E dot equipment name. And then we can go, and there it is. The equipment name and then the damage count. That is the output for query number 6. Thank you.